Hey guys, thanks for tuning in and coming back. I wanted to put together a video for my calculus class. This is section 1.3 where we are doing limits from an analytical approach, which means an algebraic approach. So I have three examples that usually some version of these show up quite a bit. And so we take a look at the first one here. And we have the limit as x approaches 0, radical 2 plus x minus radical 2 all over x. We know that we tried direct substitution first. So if we plug in 0, we're going to wind up with radical 2 minus radical 2, so that's going to be 0 over 0. And we know that that's not good because we get an indeterminate form. So we have to do something algebraic. All right, so doing something algebraic here, I want to multiply this by the conjugate of the numerator. And when we do that, we're going to wind up with radical 2 plus x plus radical 2 all over 2 plus radical 2 plus x plus radical 2. Now, algebraically, when you multiply by the same thing over the same thing, you're multiplying by a value of 1. So that doesn't change the value of the expression. But now when we multiply conjugates, it's like a FOIL. And when you FOIL conjugates, and you probably remember this from Algebra 1, if I've got x plus 4 times x minus 4, and you do your first outer inner last, and you'll see that you're going to wind up with x squared plus 4x minus 4x and then minus 16. The thing that happens every time in the middle is that they cancel out. So technically all you have to do is multiply the first term and the last term when you multiply difference of squares, or in this case conjugates. So going back here, when I multiply radical 2 plus x times radical 2 plus x, the radicals will cancel and I just have 2 plus x. And then minus radical 2 and a plus radical 2, I'll have a negative 2 here because you got a negative times a positive. The bottom, really don't need to distribute or do anything. I'm just going to multiply the bottom as x times the quantity of the other one here of 2 plus x and plus radical 2. And hopefully things start to happen here algebraically. And as you can see here in the numerator, the 2's, you got a positive 2 and a negative 2. That cancels. And then you also have the x's in the numerator, and the denominator will cancel. And what you will see here is we're left with a 1 in the numerator and just a radical 2 plus x and a plus radical 2. So we've simplified the expression down to this, and now we can bring back what we had in here, the limit as x approaches 0. And now you can do direct substitution. We can plug in 0 right here, and you will see that we'll have 1 over radical 2 plus radical 2, and you can see we have how many radical 2's? We have 2 of them. 1 over 2 radical 2. And as you know, this is a perfectly good answer. If you also need to rationalize this because you don't like radicals in the bottom, but you know it's not a big deal to have a radical in the bottom, you would have, by multiplying here, we would change this to radical 2. We would multiply the top and bottom by radical 2, and you would see that we would get radical 2, and then radical 2 times radical 2 is just 2 times 2. We'd have radical 2 over 4. So technically speaking, this is an okay answer. I'm sure the back of the book is going to oversimplify things, and we get this answer as well. So that's one example that shows up quite a bit where we have to multiply the numerator by its conjugate. Okay, I want to show you another one here. Let me scroll down. This looks really complicated, what we got going on here. We got this bracket here in the top. We've got 1 divided by x plus 4 minus a quarter all over x. So again, if we try to plug in 0, we'll get 0 over 0. Now this will be a lot simpler and a lot easier to look at if I write it out here as 1 over x plus 4 and then minus 1 over 4 all over x. So alright, so I got to think about something algebraic. So probably I got to try to do some scratch work here of putting these together in the numerator. So what do you need in order to combine like terms? You need common denominators. So I guess the best thing to do right now is, we know that multiplying the 2 of 4 times x plus 4 and 4 times x plus 4 will probably be the best way to go about this here. The first fraction is missing a 4. Second fraction is missing an x plus 4. Alright, so now that I have a common denominator, I can put those together. Now here's the thing you got to remember. You are subtracting. So that has to be distributed to both. So I'm going to have in the numerator 4 minus x minus 4 all over 4 times x plus 4. Alright, let's take a look what happens now. We can see we got the 4's to cancel, and we are simply left with a negative x over 4 times x plus 4. Now we got to remember here, this is the scratch work for the numerator. This is all over x for that part right here. That's the denominator, okay? So now when we simplify this expression, you should hopefully see algebraically that this x and this x actually cancel out. So when it's all said and done, I'm going to bring the limit back into this here. I got the limit as x approaches 0. Now what was left in the numerator here? We're going to have a negative 1 left in the numerator. And we're going to have a 4 times x plus 4. And now we can actually do direct substitution. That 0 can get plugged in for x right here. And we're going to see that we're going to have a negative 1 over 4 times 4, which is going to give us a negative 1/16 for an answer with this one. So there was one where we had to actually combine fractions in the numerator, do some algebra, combine some like terms, cancel some things, and then go back to direct substitution for that one. The last one I want to show you, all right, is one that we've seen in previous versions of our test, and that is one with a difference quotient. Okay, let me find it over here. There we go. I got the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And we're going to do this for radical x. Alright, so now if I just concentrate here first on the difference quotient part. Alright, so remember here that this is what I got to do first. I got to evaluate the function for x plus delta x. So that means wherever I see an x, I got to put an x plus delta x. So I'm going to have the square root of x plus delta x. And then I got to do this second. And I got to subtract the original. So subtract f of x. So that makes that a minus radical x. And this is all over delta x. So I got the limit now as delta x approaches 0 of this. Now if I try direct substitution right now, 0 goes in for delta x, and I got radical x minus radical x. That's 0, and I get 0 over 0 again. So this is another case, just like the first example, where I have to multiply by the conjugate. So the conjugate is going to be x plus delta x plus radical x. And then again, x plus delta x plus radical x. So just like we did in the first example, I'm going to treat this like a FOIL. And I know because they're conjugates, all I got to do is multiply the first term and the last term. And then you will see here that radical x plus delta x times radical x plus delta x is just going to give me an x plus delta x in the top. The radical x is when you multiply them, because one's negative and one's positive, is going to be a minus x. And then on the bottom, no need to multiply everything. I'm just going to keep this as delta x times this quantity here of x plus delta x plus radical x. And then hopefully, just like always, something's going to cancel here. I got the x's are going to cancel. I got the delta x's are going to cancel. And I'm going to see what's left here. I'm going to have the limit. Delta x approaches 0. I'm going to have a 1 on the top because everything canceled out there. Radical x plus delta x plus radical x. And I'm going to have 1 over, now again, direct substitution, 0 is going to go in right there. I've got 2 radical x's on the bottom. I got a radical x plus radical x, which is 1 over 2 radical x. And just like before, this is an okay answer. And if I need to, again, this is fine right here. The back of the book will oversimplify this. So I'll take 1 over 2 radical x, and I will multiply it by its, or I'll rationalize this, 1 of radical x over radical x. And you will see here that I will wind up getting radical x times 1, which is radical x, and then this just winds up being 2x on the bottom. That's another way of writing an answer so that there's no radicals in the bottom. So this is an okay answer. I like that one, and that one you're going to see probably on multiple choice where it's rationalized, or the back of the book. So there are 3 examples there of doing some limits analytically that would show up often, that require probably the most algebra that we're going to see there to try to manipulate the expression. So thanks for tuning in, and hopefully that video helps you.